So far, in describing motion of objects, we ignored one very important force, that is the force of friction that exists between surfaces. If you look at motion all around us, most of these motion occurs one surface relative to another. That means an object is moving on a surface, which obviously brings in the force of friction between surfaces. So this is a force we cannot ignore. In this lesson, we will look at the force of friction between moving surfaces. Well, I have set up a simple surface. I'm going to make it move on the desktop. And in order to move, I need to apply force. And I have a scale that will measure that force in Newton. Can you read this? This is 0, 1, 2, 3, and so on. And watch me apply a force. And if you notice, I'm actually applying a force now. A force of 1 Newton. Why isn't the surface moving? Why isn't the block of wood moving? Because the friction is opposing the applied force. The friction is opposing motion. I'm going to increase the applied force to 2 Newton, to 3 Newton. You see, it's still not moving. So what does that mean? It means as you increase the applied force, the friction also increases. Well, let me increase the applied force to 3 Newton, to 4 Newton. Well, I have now broken the friction. Now, what that means is, as you increase the applied force, the frictional force between the two surfaces will increase. But the frictional force cannot keep on increasing. There is a limit. The maximum frictional force between two surfaces is called the force of limiting friction. I will write down that on the board later, but let's do some discussions first. So what is the force of limiting friction? A force of limiting friction is the maximum frictional force that exists between two surfaces. Well, tell me, what is the reason for frictional force? I have a block of wood here, and the block of wood is to be made to move on the surface of the table. What is it that causes the frictional force? Well, the frictional force is actually caused by various reasons. The simplest explanation probably is the interlocking of the minute infractions, let us say, because if you look at the surface of any object, although it looks smooth, there are ups and downs on any surface. So when you keep one surface on top of another, there will be interlockings of these imperfections. And in order to move one surface over the other, you need to overcome that. Now tell me, what is the factor on which the force of limiting friction depends on? Well, if you can increase that interlocking, in other words, if I can increase the normal force, then I would expect the frictional force will be greater. Is that right? If I press harder on the block of wood, it will be difficult to move it. All right, let's have a look at that one more time. Now, when I increase the applied force, now I had some masses kept over here. When I increase the applied force, can you read the force there? The frictional force increases, and there you are, about 4 Newton. I need about 4 Newton force to overcome the friction. That means the force of limiting friction in this case is about 4 Newton. Now, I'm going to put another mass on top of this block. What does that do? that will increase the normal force. In other words, that will increase the force pressing this block onto the table. And now you watch what happens. Well, I'm actually crossed 5 Newton. Yes, I need about 5 Newton to move this now. The force of static friction is now 5 Newton. Now, I'm going to increase the normal force by putting more weight. I can see now, well, I need a lot of force. There, I needed about 8 Newton to set it in motion. That means as the normal force, the force pressing the two surfaces increases, the force of limiting friction also increases. So if I ask you, what is the factor on which the force of limiting friction depend on? Well, one answer is the force of limiting friction depends on the force that presses the two surfaces together, which we call the normal force. And what is the normal force in this case? It is the weight of this block, the total weight, or the normal force equal to mg when the two surfaces are horizontal. Okay, let's put this thing. So, what is force of friction? Friction is a force that always opposes motion. A box of mass m placed on a surface A and a force, an applied force F tends to move it. The applied force F wants to move it to the right. Now what happens? The frictional force F between these surfaces will oppose the motion, will be acting in the opposite direction. And we will represent frictional force by the lowercase f. Now, if the applied force F is not sufficient to overcome this frictional force, then the box will not move. As the applied force increases, the frictional force also will increase until it reaches a maximum value. And what did we say that maximum frictional force between two surfaces is called? It is called the force of limiting friction. The maximum force of friction between two surfaces is called the force of limiting friction, and we will represent that with the lowercase f. Now, so whenever we talk of friction between two surfaces, we actually mean the force of limiting friction, and that will be our lowercase f. Now, what are the factors that affect the force of limiting friction between the two surfaces? I just illustrated that to you here. What is the one factor that affects the force of limiting friction? The one factor that affects the force of limiting friction is the force that presses the two surfaces together. In other words, it is the normal force. And when the two surfaces are horizontal, the normal force is the weight of the object that is being put in motion. The only factor that affects the force of limiting friction is the normal force, that is the force that presses the two surfaces together. Now, we have talked about this normal force several times. When the two surfaces are horizontal, the normal force is equal to mg, the weight. Now, do you remember, if an object is placed on an inclined plane, well, when the object is placed on an inclined plane like this, what is the normal force in such a case? Anybody remember that equation that we developed? When the block of wood is on an inclined plane, there you are. What is the normal force pressing the wood onto the surface? will be mg cos theta. Is that right? Yes, we will be looking at that as we move on. So whatever the normal force is, the force of limiting friction will depend only on the force of normal, the normal force between the two surfaces. Well, of course, it depends on the nature of the surface. We are talking about for given two surfaces, the force of limiting friction depends only on the normal force. Now, let's now talk about the concept of coefficient of limiting friction. Coefficient of limiting friction. Well, this can be obtained, or this concept can be explained by the fact that the frictional force is directly proportional to the normal force. You increase the normal force, you increase the friction. So, what is the normal force that is pressing the two surfaces together here? The two surfaces are horizontal, therefore the normal force is the weight mg of the box that is acting down. Well, mg is acting down and the surface will apply a force F sub n upward, and this is the normal force pressing the two surfaces together, and this Fn equal to mg. Is that right? The normal force equal to mg, and it is that normal force that presses the two surfaces together. That means we can now make a statement which can be called the law of friction. What does that say? The force of limiting friction, lowercase f, is proportional to the normal force Fn. Can you write that down using your mathematical notation? Lowercase f is proportional to the normal force. We write it like this. F is proportional to Fn. And a statement like this, you know, can be written as an equation. Now, what will be that equation? The proportional sign can be replaced by an equal sign. Alright, so F is proportional to Fn can be written as F equal to a constant multiplied by Fn, and this constant is what we call the coefficient of friction between the two surfaces. Alright. Now, because Fn equal to mg, we can now write this as the force of limiting friction equal to mu times mg. The force of limiting friction between two surfaces that are horizontal with respect to each other will be equal to mu times mg. A very important relation. That means mu can be calculated as the force of limiting friction divided by mg. Okay. Let's now talk about kinetic and static friction.